Dear students, now in this session, 14th session, we are going to discuss a problem, that is the Chinese postman problem. In the previous class, we have discussed the traveling salesman problem. That was the application of Hamiltonian graph. That is finding a Hamiltonian graph which has got least weight. Of course, there are different Hamiltonian graphs in a graph, okay, but out of those Hamiltonian graphs you have to find out a Hamiltonian cycle with minimum weight. That would be the solution for the traveling salesman problem that already we have discussed in the previous class. Now today we are going to discuss the Chinese postman problem. So therefore, the Chinese postman problem. Let me give some brief introduction about this Chinese postman problem. In the year 1962, a Chinese mathematician called Con Mei Ko. So he was a mathematician, was interested in a postman delivering mail to a number of streets such that the total distance walked by the postman was as short as possible. The Chinese postman problem is an application of an Eulerian graph. See, the traveling salesman problem was application of Hamiltonian graph. Now here the Chinese postman problem is an application of Eulerian graph. So this is the brief introduction about the Chinese postman problem. So now what is the Chinese postman problem? A postman begins in the post office, has to traverse all the streets and returns to the post office in a shortest possible distance. Let me compare the traveling salesman problem. There, the traveling salesman problem has to start from one of the place, visit all other places and come back to the same place where he started. Here the Chinese postman problem, he has to start from one place of course, but here street means roads. Exactly once he has to traverse. Okay. So there vertices are given importance. Here edges are given importance here. So a postman begins in the post office, has to traverse all the streets and returns to the post office in a shortest possible way. See, for example, this is the post office. Okay, so he has to visit all other places, of course, but he has to trace every street exactly once. Exactly once. Okay, so like that, he has to come back to the post office by distributing the letters. Okay, suppose that a postman delivers mail to every house in his area. He wants to cover the route in the most efficient way and then return to the post office. Consequently, the postman must devise a route that traverses every street section between consecutive intersections at least once. Yet minimize the total number of times it is necessary to walk down a given street. The problem of finding such a route is called the Chinese postman problem. So now we will give the graphical representation of Chinese postman problem. The intersections of street sections corresponds to the vertices of the graph. Here the intersections of the street sections corresponds to the vertices of the graph. And when two vertices are adjacent of the street that joins the corresponding intersections does not meet a third intersection, the resulting graph is the graphical representation of the Chinese postman problem. For a connected graph G, determine a shortest closed walk covering all the edges of G. Such a closed walk of G is called an Eulerian walk of G. You know already what is an Eulerian walk. Eulerian walk of G is nothing but it is a closed walk containing all the edges, and each edge is traversed exactly once. So in that way you have to find out a root. It implies to solve the Chinese postman problem, we need to find out a Eulerian cycle, or you can say a closed walk. So that we need to find out, and that will be the solution for the Chinese postman problem. But to understand in detail, we need to construct some algorithms, or we need to refer some books where we will get the application part of these. So there are some algorithms. So because of the time, stipulated time, so there is no much more time to spend on these applications part. Just we have highlighted how a graph theory is used to solve some problems, real life problems. So one is traveling salesman problem. Now another one is Chinese postman problem. If you want to go through all these things in detail, better you can refer a graph theory book written by Nursing Dev. There you will get plenty of application part of the graphs. Okay, so with this we conclude the today's session. So what we have discussed in this session, we have discussed the Chinese postman problem. Then we have given the graphical representation of the Chinese postman problem. So it implies the solution to the Chinese postman problem is nothing but you are finding a closed walk. That is, you are finding an Eulerian cycle of the graph. Here also again it is a weighted graph. It implies every edge is given a weight, means a real number is assigned to every edge. So here also we are finding, of course, there will be one Eulerian cycle. If degree of every vertex is even, obviously there will be one Eulerian cycle. If not, suppose there are some vertices with odd degrees, what to do? So for that there are some algorithms. So those part, if you are interested, you can go through such books, because just we in this session we are only highlighting how the concepts of graphs are used to solve some problems. Thank you.